In this tutorial, I'll demonstrate how we can use Excel functions to generate measures of central tendency and also measures of dispersion. The data we'll be using here is hypothetical student exam and age data, and I've already generated two additional sheets where I've copied the data here under the Central Tendency tab and begun to generate then a table where I will report the various measures of central tendency. Now the three measures we'll demonstrate, of course, will be the mode, that is the most frequently occurring case, the median, that is the case which falls in the middle of a set of data once our quantitative variable is ordered from low to high, and then the mean or the arithmetic average. To generate, first of all, the mode, what I'll do here is demonstrate how we can use one function, and that is the mode function in Excel that generates a single mode. And let's do that first of all for exam number 1. So I've just clicked here under exam, the variable name, next to mode. And what we'll do is, as we always do whenever we type in a formula or a function, begin with equal sign, and it's mode dot, and you notice here there are two different forms of the mode function, and what we'll do is use the single mode. This generates a single value for the mode. Open parenthesis, and now I'm going to highlight the data range and then close parenthesis and hit enter. Now what we have here is an error, and what this error indicates in essence is that there is no mode to be reported here. Every single case, or every single value I should say, for exam 1 in these data only occurs once. But let's now see if there is a modal value for the variable age. Again, I'll use the mode single function equal mode dot or period SNGL, open parenthesis, and I will highlight the data range for the variable age, close parenthesis, and hit return. Now you notice it does generate a numerical value. So 23 occurs more often than any other value for age for these 17 students for this hypothetical class. Now, one of the things with a mode single function is that it only returns one value, and there may be several values that actually have the same frequency of occurrence. What we have here is the variable age indicates 23, and that would be fine. We could stop here as long as we were confident that there were not other values that had that mode as well. Now one of the things I'm going to do right here is I'm going to go ahead and reorder these data. And I'm just going to choose random. I'll order the variable exam 1. So come here to data. Once I've highlighted all the data I want to sort, I'll come over here to sort, and I'll sort on the variable exam 1, and I'll click OK. Now you notice what happens here is the mode now changes from 23 to 25. Well, what happened here? Exact same data we have here. I have not changed the numbers that have been entered in. All I've changed is the order in which they appear. Now what this indicates here is that what the mode.sngl, or the single mode function in Excel, does, it reports the mode, the first occurring value for a modal value. In this case, as we scroll down here the variable age, you'll notice that we have 25 occurs and then 23. And what we'll notice in a second is that 25 and 23 both occur 3 times. So what we see here is while 25 and 23 are both modes, the .sngl function in Excel will only report the one that first occurs in the data order that we've got arranged. Now as I go back and undo the sort that I've just done here by exam 1, why does it change from 25 to 23 for the modal value? Well, because if we start to scroll down here, you notice 23 occurs before any value of 25 occurs. So one of the things we'll need to do then is to make sure that we only have one value that occurs more often than others for us to use the mode.sngl function in Excel. Let me go ahead and clear that. And what we're going to do now is introduce the second function that's used for generating the mode, and that is the mode.mutl, which stands for multiple modes. Now, to use this function, the first thing we'll do is highlight several different cells in a column, and this is referred to as an array function that we'll be using here. An array of cells is where the output will be generated, or a list of cells. And now I'm just going to move up to the formula bar and start to type in the function equal mode.mult, open parenthesis, and now I'm going to highlight the data range. That is where the data are that I want to find the mode from. Close parenthesis. Now resist the temptation or the habit of just pressing the enter key. We actually have to enter this as an array formula. That is so that the formula will be entered in for each one of these cells that we've highlighted. To do that, I'll hold down the Control and Shift keys on a PC and then hit the Enter or Return button, Return key. So to enter in an array function, hold down Control Shift and then press the Return key or the Enter key. And what that does, it enters then the formula into all the cells that were highlighted. So if I click on the very first cell where the formula was entered and then start to scroll down, you notice that same formula is entered in all of those cells that were highlighted. Now, how we know that this is an array function or an array formula that we've entered here, if we go up to the formula bar, you notice that at the beginning we see a bracket, and at the end we see a bracket. Now, I did not type that in, but when we do Control Shift and then hit Enter, it automatically adds those brackets to the formula we have here. Now, if you happen to be using a Mac computer instead of a PC, then what you would want to do is hold down the Command key and hit Enter in order to enter in an array function. So again, Command and then press the Return or the Enter key on your keyboard. Now, we cannot delete one cell for this formula. If we wanted to get rid of this function here, the results, we'd have to highlight all of the cells and delete them. Now, one of the problems that I see here, well, first of all, you notice here that age now has 3 modes, 23, 24, and 25. So not just 1 or 2, there actually are 3 modes. And what I've done here is it enters it in as a column array, but that then puts the value of 24 for the modal frequency and the value for 25 for the median, and it looks like then that there is no mean that exists for the variable age, which we of course know is wrong. What I would like to do instead is to have the modal values to actually be reported in the row for the mode for the variable age, not in the column. So let me now go ahead and highlight all of those cells and backspace or delete to get rid of then that formula. Now I know that there are 3 modes, so I don't need to highlight 4 or 5 cells. So I'll just highlight 3 cells. Now I'll type in equal, and in order to change it from a column output to an array that we see is in a row, I have to now type in a command transpose. Transpose. Now what we're going to do now is we're going to embed now within the transpose function the mode.mult function. So I'm putting the mode.multiple function inside the transpose function. Open parenthesis, and now I'm going to highlight the data range for my variable, close parenthesis. Now that only closes then the function for mode.mult, and now I have to add a second close parenthesis in order to complete then that transpose command. Now again, resist the habit of hitting the enter key What we want to do is hold down the Control, Shift, and then press Enter to enter that formula. Or for a Mac, of course, we would hold down the Command and then press the Enter key. And there we have it, the values 23, 24, and 25. Now they happen to be in numerical order from 23 to 24 to 25, and that's because if we go over to the variable age, you'll notice then that 23 comes first, then there's a 24 that occurs, then there's a 25 that occurs. So they just happen to occur in order within the data that we have here. Now to ask the question or answer the question of how often does each one of these cases occur within our data, I'm going to come under the cell below 23 and I'll use the COUNTIF function to count the number of cases where we have a value of 23. Equal COUNTIF, open parenthesis, identify the data range where the variable is, comma, and now I'm going to type in the criterion that I want to use, and that is 23, and close parenthesis. What this is going to do is go find within the range of C2 to C18, those 17 cells, count the number of cases that have a value of 23, and hit return. And there are 3 cases that have a value of 23. Now, a more general way of that formula that I can use is instead of typing in the criterion here, 23, which you notice there's also 24 and 25, or other examples of the mode here, I'm going to instead just click on the cell reference for where 23 is located, and here it's in cell I4. And then I can hit enter. And again, what that does, it goes up and finds the content in cell I4, which is 23, and finds all those cases in the range of C2 through the cell C18 that have a value of 23, and there are 3 of them. Now, to copy this formula across for the other 2 modal values that we see here, let's make this a more general formula, and I'm going to fix the cell numbers, cell letters rather, to the C column. If I would just copy this formula across into cell J5, then we'll notice it would ask COUNTIF in D2 through D18. Then if I copied over one more cell into K5, it would then shift over to look for the range of E2 through E18. But I now want to keep it fixed of C2 through C18 in terms of column C. Hit enter, and now I can simply then click and drag to copy that formula across. And you notice here what it does is it changes the criterion reference, that cell reference, but does not change the reference for the data itself. So that's how we can go ahead and generate multiple modal values as well as the modal frequency for our given set of data. The next thing we'll do is generate our other 2 measures of central tendency, the median, which is the case that splits ordered data in half, equal median, open parenthesis, highlight the data range, and here I'm generating the median for the variable exam1, close parenthesis, and hit enter, and you see it's a value of 82.1. I can do the same thing here for the variable age, equals median for the function, open parenthesis, identify the data range for age, close parenthesis, and just go ahead, hit enter. And now I can do the same thing for the variable mean. I'll type in here average. So there's not a mean function, it's an average function. Highlight the data range, close parenthesis, and we see then the average here is 81.48. I'll do the same thing here for the variable age. Equal, average, open parenthesis, highlight the data range, close parenthesis, and hit return. And one of the things I'll do is I tend to like to have my mean to one more decimal place beyond what my data are. And since the data here for age is whole numbers, I'll highlight then that value, that range, or that cell I should say, come up to the home button, and I'm just going to decrease the number of reported, what we see here, the reported decimal places. Doesn't change the result, just changes how it's reported. And that's how I can easily then generate measures of central tendency using Excel functions. Now that we've computed our measures of central tendency, let's demonstrate how we can go about using Excel functions in order to generate a couple of basic measures of dispersion. The first one we'll do is generate is that of the range, which is the difference between the largest and smallest value in a data set or for a variable. What I'm going to do is first of all generate the minimum value, the smallest value for the variable exam1, equal, and I'm going to use the min function, min, open parenthesis, highlight the data range where exam1 scores are, and close parenthesis. So the smallest or the lowest exam score value here was 65.8. To find the largest or the maximum value for the variable exam1, we'll use the max function, equal to begin our formula, max, open parenthesis, highlight again the data, our data range here, D2 through D18 for this variable, close parenthesis, and hit return. And so what we see here, the maximum value is 93.6. So what I can do here at this point then is to generate the range equal, take the value in the maximum cell minus the value that is generated for the minimum cell. And we see here the range is 27.8 points. Let's do the same thing for age, equal, and I'll type in min to find the minimum value, open parenthesis, and for age, highlight the data range, close parenthesis. Youngest value, the youngest person here is 23 years of age. For the maximum value, equal, max, open parenthesis, again highlight the data range for this variable, close parenthesis, and hit enter. And we see the oldest value is 40. Now instead of simply subtracting the minimum value from the maximum value like we did for the variable exam1, let's show how we could even just generate then the range without having to report the minimum and maximum values, using again the same functions of max and min. Equal, find the maximum value, so max, open parenthesis, highlight the data range, close parenthesis, subtract from that then the minimum value, open parenthesis, highlight the data range for that variable, and close parenthesis. And there we see a range of 17. So we can use then both functions within the same formula. Now to find the variance for the variables, equal, var, and you notice there are two options here, .p and .s. The .p refers to a population computation for the variance, while the .s is a sample computation. The difference between the assumption of whether or not you have population data or whether or not you have sample data is that for population data, the formula has n in the denominator, the number of cases, while for sample data it has n minus 1. What I'm going to do here is just assume we're working with a sample. So .s, open parenthesis, highlight the data range, close parenthesis, and we see a variance here of 68.91 in essence. I can do the same thing here for age, equals var dot s for sample, open parenthesis, highlight the data range, close parenthesis, and hit return. For standard deviation, a similar function, equal stdev, and again there are two options. One is .p, the other is .s. We'll use the .s, and again the .p assumes here that you have population data, and the formula then has an n in the denominator, number of cases, while this .s assumes you have sample data, and what it does then, it assumes since you have sample data, the denominator is n minus 1. And we're going to assume that we have sample information. Open parenthesis, highlight the data range for the variable exam1, close parenthesis, and hit enter. And then we'll do the same thing, equal stdev.s, open parenthesis, highlight the data range, close parenthesis, and hit return. Now I'm going to clean this up a little bit. I like the mean here is 1 decimal beyond what the data are, and the variance, I'll keep that to 2 decimal places beyond what the data are, so 68.909, just to make it, tidy it up just a little bit. While for age, 2 decimal places beyond the original data, since the original data, the variable is in whole numbers. I'll leave that to 2 decimals. And the same thing we'll do for standard deviation. Now, one thing I wanted to point out here is we can compute, for example, standard deviation or variance a couple of different ways without having to use each of those functions separately. For instance, let's say we have already generated the variance or do generate the variance, equal var.s, open parenthesis, and highlight the data range. And we should get the same value we've had already. Now I can very easily then use this function, embed it in another function, and that being embedded in the square root function, sqrt, open parenthesis, and now I have to end with another parenthesis. And this should give me the value for a standard deviation. Hit return, and you notice here I have the value of 8.301. So I've embedded then the var.s function within the square root function to generate standard deviation without using the standard deviation function itself. By the same token, what I can do is take the standard deviation function, equal stdev.s, again assuming a sample, highlight our data range here, and that'll just simply then generate the standard deviation that I have here for variable age. And I can take that now and just merely caret 2, and that caret refers to raised to the power of 2, to square then the standard deviation. You notice what we get now is the variance. So I just wanted to show you that we can use other sorts of functions in combination with a function that we're demonstrating here. But let's get rid of that. And what we have here now is our table of descriptive statistics.